A warm welcome to the channel. This is the one in which I am going to solve the problems on control systems, which is normally asked in the gate questions. So today I'll start with the electrical circuits and the problem related to electrical circuits. We'll see the basic concepts of an electrical circuit, what are the components present in an electrical circuit, and how to write the differential equations, how to take the Laplace transform of those equations, and how to solve a simple problem. So as we know, we have mainly three components in an electrical circuit. One is the resistor represented by R. Second is inductor represented by L. And the third component is capacitance represented by C. And how to write the voltage equations for individual components. The voltage equation of resistance is I into R. The voltage across the inductance is L into di by dt. The voltage across the capacitance is one by C integral of I dt. So these are the three terms which we already know, and these are the important things which we have to remember when we are writing the differential equations for the system and when we write the transfer function of an electrical circuit. Now, for obtaining the transfer function, the definition of the transfer function is we have to take the Laplace transform of output by Laplace transform of input. Laplace transform of output by Laplace transform of input at zero initial conditions. This is very important term when we define the transfer function, because we are not going to consider the energy which is stored in the energy storage elements when we start doing the problem. That is the main thing when we represent as zero initial conditions. So since this is the condition which is going to be considered for the transfer function, when we are taking the Laplace transform, even if we have differential of one term, we are not going to extend the Laplace transform as x of 0. We'll stop only with the input variable x of s. That is the main thing what we have to remember. Okay. So considering this in mind, I'll write the Laplace transform of the individual terms by the sideways. So when we take the Laplace transform of the voltage across the resistor, it should be, since we have only I, which is the varying parameter there, we don't have any variation of that parameter with respect to time. So it is simply I of s into R. Okay. So when we go for the inductor, here we have differentiation of the current with respect to time. It is di by dt. We are going to represent that as Laplace transform. Laplace transform is the one where the time domain is going to be represented in frequency domain. Here if you see, the time domain and the frequency domain are inversely related. Time and frequency are inversely related. So if you see here, it is with respect to rate of change of time dt, that is time is in the denominator term. So we are going to represent that as the Laplace transform, which is the frequency term. So we have to multiply S into L into I of S. So whenever we have dI by dt, since it is time is in a denominator, it has to be replaced by S term, which is j omega frequency. So time inverse of time is frequency, so it is represented in numerator. L already we have in this equation, so it is replaced by L, and the variable which is varying is I, so we are writing it as I of S. Now coming to the third term, which is the capacitor. Here we have 1 by C is already in the equation, so it is replaced by 1 by C. And here we have I as the varying parameter, so it should be represented as I of S. And T is multiplied with that variable. It means that we have T in the numerator, so we have to represent as the frequency in the denominator polynomial into I of S. So we have to remember only these three parameters when we have resistor R into I of S, when we have inductor L into S into I of S, when we have capacitor 1 by CS into I of S. I saw a simple problem today. Okay. So this is the problem for which we have to obtain the transfer function. Here we have R1, R2 and capacitor, and the input voltage is represented as VI and the output voltage is represented as V naught. Now for this problem, we have to obtain the transfer function. And this is a gate question which is asked recently. And when we are finding the transfer function, again I will repeat the equation. Transfer function is Laplace transform of output divided by Laplace transform of input at zero initial conditions. So this is the transfer function equation. Now we have to write, as we know, we have to write take the Laplace transform of output and the Laplace transform of input. So we have to write the input equation and output equation for this problem. When we take the input term, that is voltage, and output is V naught, that is the output voltage. Here they have not represented the current, but we can take by our own I1 or simply I as the current. It can be I also because we have only one loop in this problem. Now, when it is a gate question, we should not take much of our time for taking or separately writing the equations individually, and we should not waste our time in taking the Laplace transform. But anyhow, since this is the first problem, I'll say you how to write the equation for this problem. So if it is VI, first we have to start writing the input equation. VI is equal to, that is a KVL law, the voltage rise is equal to the sum of voltage drops. VI is the input voltage, source voltage, so that is voltage rise is equal to the drops will occur in R1, R2 and C. So R1 can be written as R1 into I1 as I explained in the basic step. R1 into I1 plus what is the next element? We have R2. So it has to be written as R2 into I1. Same current is flowing. Plus we have capacitance which can be written as 1 by C integral of I1 dt. You number this as first equation. Now we have to take the Laplace transform of this particular equation. So when we are taking Laplace transform, we have to remember what is the basic step what I have given. So taking Laplace transform of first equation. Take Laplace transform of 1. So when we take Laplace transform of 1, when it is R1 into I1, it should be R1 I1 of S. Okay. Second term is R2 into I1. So it should be plus R2 I1 of S. What is the third term? It is 1 by C integral of I1 dt plus 1 by C should be written as it is. Since it is a dt term, it is 1 by Cs I1 of S. Number this equation as 2. On right hand side we have Vi. So this should be equal to Vi of S is equal to. So Vi of S is equal to R1 I1 of S plus R2 I1 of S plus 1 by Cs I1 of S. So in this equation, we can take I1 of S as the common term. So I1 of S, which should be taken as the common term, can be written as R1, R2 plus 1 by C into S. Number this as third equation. Now we have to write the output equation because the Laplace transform of output by Laplace transform of input. So you start writing the output equation V naught. So in the problem they have mentioned V naught is the output voltage across R2 and 1 by C. So it should be R2 into I1 plus 1 by C integral of I1 dt should be the output equation. Now we have to take the Laplace transform of this output equation. Take Laplace transform of fourth equation. So this will become V naught of S is equal to, this should be written as R2 into I1 of S plus 1 by CS I1 of S. Since we have I1 of S as the common term in both the terms, we can take I1 of S as the common term. Within brackets, it should be R2 plus 1 by CS. You number this equation as 5. Now we have third equation where Laplace transform is taken for input, and we have fifth equation where output voltage is taken with the Laplace transform. Now what is the transfer function? It is the Laplace transform of output by Laplace transform of input. So we have to consider third equation and the fifth equation. Okay. So transfer function is equal to output by input. So output is represented in fifth equation divided by input is represented in third equation. So it is V naught of S divided by Vi of S. We have to take the ratio. So transfer function is equal to, here it is R2 plus 1 by CS divided by R1 plus R2 plus 1 by CS. So you take LCM, it will become R2 CS plus 1 divided by CS in the numerator whole divided by R1 CS plus R2 CS plus 1 whole divided by CS. CS in both the terms will be cancelled out. So we'll get R2 CS plus 1 divided by CS is common in the denominator polynomial. So it will become R1 plus R2 plus 1. This is the transfer function for a simple electrical circuit where we had two resistors and one capacitance. So we'll continue with such kind of gate problems in the forthcoming classes. Thank you.